Welcome to today's class. So for today, we talk about computer architecture. Like that's the main topic, like the course. But today we focus on why the data path cycle has a huge impact on the performance of the CPU. So to start with, we are going to check on some few things. So from the slides, it says the data path cycle has a significant impact on CPU performance because it determines how quickly and efficiently data can be processed and transferred within the processor. And here is why it matters. One is the data flow through the CPU. The data path refers to the set of components within the CPU responsible for processing, storing, and moving data. This includes registers, the arithmetic logic unit, that is the ALU, the buses, the multiplexers, and other functional units. Again, is the time it takes for the data to travel through this part, which includes fetching instructions, decoding them, performing arithmetic operations, and writing the result back to the memory registers. 2. Cycle time and latency. The cycle time refers to how long each clock cycle lasts. A shorter cycle time means the CPU can perform more operations in the same amount of time. A longer data path cycle introduces more latency, meaning that the CPU takes longer to execute each instruction. This directly increases the time needed to complete tasks, reducing overall performance. Critical path and bottlenecks. The critical path is the longest sequence. The critical path is the longest sequence of dependent operations in data path that determines the minimum possible clock cycle time. If the critical path is long, it increases the overall time. It increases the overall cycle time, slowing down the processor. 4. Pipelining and parallelism. CPU use pipelining to improve throughput by allowing multiple instructions to overlap in execution. The data path cycle impacts how efficiently instructions can be processed in parallel. If the data path cycle is long, fewer instructions can be processed in parallel, reducing the benefits of pipelining. 5. Clock speed versus data path cycle. The clock speed is determined by how fast the CPU can execute a cycle. The clock speed is limited. The clock speed is limited by the longest delay in the data path. A long data path cycle means a lower clock speed, which in turn reduces the number of instructions the CPU can process per second. 6. Complex operations and multi-cycle instructions. In CPUs, the complex data path, some operations may require more than one cycle to complete. Example, memory access or multiplication operations. If these operations take multiple cycles, the overall throughput of the CPU decreases. Optimizing the data path to handle multiple operations more efficiently can reduce the number of cycles required for complex instructions. Impact on performance metrics. The instruction execution time and throughput are both influenced by the data path cycle. If data can be moved and processed faster, the CPU can execute more instructions per second, that is higher throughput, resulting in better overall performance. Conversely, a slow data path cycle increases the time it takes to process each instruction, limiting the CPU's overall performance. So, thank you all for watching this video and stay tuned for more.